Over the years, Ethereum has brought all kinds of advancements into the cryptocurrency space, including smart contracts and high-interest paying decentralized applications. However, it faces three big challenges. The first is the low throughput issue, which is a fancy way of saying Ethereum can only handle 30 transactions per second. For the amount of people that are actually using Ethereum, this processing speed is considerably low, since many alternatives can process many more transactions in the same time frame. For example, the Cardano blockchain does around 257 transactions per second, while Polkadot can do up to 1,000 and Solana all the up to 65,000. The second big problem is that the Ethereum network isn't really user-friendly, since you are effectively bidding in an auction against everyone else. Who wants to be one of those 30 transactions? In short, this means it is expensive. And I mean like $20 just to send your friend $1 expensive. Lastly, the Ethereum blockchain presents developers with limited options. All Ethereum projects run on the same network and have a similar throughput. This implies that they all share in Ethereum's problems with no exceptions. But what if there was another blockchain that leveraged Ethereum's technology while also offering higher throughput, extremely low transaction fees, and better options? Welcome to Crypto Jutsu, the #1 YouTube channel for crypto education, and here we explain topics of the cryptocurrency world using analogies, stories, and examples so that you can easily understand them.
In this video, we're going to explain what Polygon is, how it works, as well as the specific tokenomics of the MATIC coin. So in 2016, 3 Indian developers sought to find a solution to Ethereum's problems, which resulted in the creation of MATIC, which is now rebranded to the Polygon network. Now, one thing to note here is that even though they rebranded to the Polygon network, the coin is still called the MATIC coin. Polygon is a layer 2 scaling platform
that allows Ethereum-based applications to tackle the problems that I mentioned earlier, while also leveraging Ethereum's security. Its primary focus is to increase the usage of DeFi tools and applications. By basically connecting blockchains together, the network currently hosts over 3,000 decentralized applications, of which over 80 big names migrated from the Ethereum main chain. Since Polygon is so similar to Ethereum, many creators that develop useful tools will actually move them from Ethereum to other EVM blockchains like Polygon. That way they can increase their reach and usage. Now, if you're wondering what EVM is, it stands for Ethereum Virtual Machine, and it's the actual code that is ran by computers around the world to actually carry out the blockchain's smart contracts. Now, I must say at this point in the video, if you have no idea what hardly any of these words I mentioned are, you can watch some of our dedicated videos that explain some of these terms. Anyways, Polygon actually has an EVM, but so does the Binance Smart Chain, Phantom, and a few other big networks. They all utilize the main Ethereum code. And since they run basically all the same code, it makes sense how developers can simply move their project over to a new network and it'll work basically the same way, without making many changes. Moving on, when we think about Polygon, most people think about the Polygon proof-of-stake chain, which is simply a side chain to Ethereum, utilizing a proof-of-stake consensus mechanism. There's a few other changes to this sidechain, but what's really important is that it's way faster and can handle way more transactions per second, also meaning it's much more affordable to the end user. Well, technically the Polygon network is a lot more than just a sidechain. One of the core ideas behind Polygon is to equip developers with user-friendly and flexible tools. That way they can fast-track Ethereum's transformation into a multi-chain platform. To put this in simpler words, Polygon isn't just a single proof-of-stake chain that we usually think of. They are a series of blockchains that can help scale Ethereum. When they actually achieve this, developers can easily create all kinds of different scaling solutions that they can use with Ethereum, like completely separate chains like ZK rollup chains, optimistic rollup chains, or any other side chains that they desire. By the way, you can check out our videos on sidechains and rollups if you want to learn more about how those specifically work. They're really unique and creative ways to bundle up data and save space on the main Ethereum chain. The Polygon proof-of-stake chain is just one way to scale Ethereum. In reality, Polygon plans to create many different solutions for users to scale it, so at first glance, I thought Polygon was pretty simple. But when you look at its internals, there's a lot more than regular users see. For users like you and me, we can sum up Polygon in one sentence: It's basically Ethereum but with super cheap gas fees. Right now, to transfer your Ethereum from one account to another, the fee is like $20. However, on the Polygon network, it is less than a penny. This means users are free to try out new apps and test things out without the fear of losing a $150 over a token swap. Personally, the Polygon and Binance Smart Chain are the 2 DeFi blockchains that I recommend to new users. So take that for what it's worth. Moving on, let's get into a little bit more about how Polygon actually works. So Polygon is driven by the layer -2 scaling solution and the proof-of-stake protocol serving as what is called a commit chain to the main Ethereum chain. Now if you don't know what a commit chain is, it functions as a transaction network that operates close to the real chain. Therefore, in Polygon's case it actually works alongside Ethereum. Now before we continue, a lot of the future stuff I'm going to be talking about is pretty technical. But if you're interested, let's dig in. The Polygon commit chain groups up clusters of transaction and processes them all together before sending the data back to the main Ethereum chain. Think of it like this: instead of sending an entire video of all the transactions, Polygon simply takes a single snapshot every now and then, so that the Ethereum chain can still understand what is happening but without processing tons of data. This is why the Polygon network can actually up to 65,000 transactions per second. Some experts predict that a time will come when developers will host thousands of chains that work hand in hand with Ethereum to increase throughput all the way up to millions of transactions per second. Now let's get a little bit more technical. Polygon's architecture runs on a 4-layer system comprising of the Ethereum layer, the security layer, the Polygon network's layer, and finally the execution layer. Now I'm gonna be honest with you. You don't really need to know this stuff, so skip ahead if you want to get into the tokenomics. The Ethereum layer is made up of different Ethereum-based smart contracts. These contracts are in charge of staking, transaction approval, and interaction between the Ethereum blockchain and
numerous Polygon chains. This layer is how Polygon actually checks in with Ethereum from time to time.
Next up we have the security layer, and it works alongside Ethereum to provide validator services, giving chains an additional layer of security. That said, it's important to note that both the security layer and the Ethereum layer are actually optional. They are not required for Polygon to work. Layer 3 is the Polygon network's layer, and it's the ecosystem of projects or blockchain networks developed on Polygon. Basically, every project or blockchain that exists within this ecosystem has its own community, where local consensus is reached and blocks are produced. Finally, we have the execution layer. This is popularly known as Polygon's Ethereum virtual machine, and its main function is to execute smart contracts on the actual Polygon blockchain. The compatibility with the EVM, like I mentioned earlier, smoothens the user experience for developers and programmers using the Ethereum chain. Finally, let's get into the Polygon's tokenomics. The Polygon network has a native token. It's called MATIC, which has been trading for around $2 with a market capitalization value of around $13 billion. MATIC tokens are dispersed monthly and have a total supply of 10 billion tokens, of which nearly 6.8 billion is already in circulation. The difference between these two numbers is that tokens that are held for staking rewards and tokens with a time-locked release schedule that we'll talk about later. Initially, the developers sold around 3.8% of MATIC's total supply in their initial private launch all the way back in 2017. Then later, they had an initial exchange offering where they sold another 19% of their max supply. If you're wondering where the other tokens are, the development teams own 16% of the supply, the advisors have 4%. Staking rewards come to around 12%, the ecosystem already has 23%, well around 22% went to the Polygon Foundation, and since MATIC tokens are technically being printed to reward stakers right now, it is technically inflationary. However, MATIC does have a limited supply and soon they will be implementing their version of EIP 1559. If you have no idea what that is, what it basically means is that base transaction fees will effectively be burned, which MATIC will eventually be a deflationary token. Now if you're anything like me, you might be wondering, how are they gonna reward the stakers when the funds run out? Well, the Polygon team will hope by then the extra transaction fees that users add to prioritize their transactions above the base fee will be enough to incentivize staking validators to keep doing their thing. To wrap this video up, personally I love Polygon ecosystem to invest in. namely the Curve finance application, and it has actually earning me around 30% APY for the past few months. Aave on the Polygon network also had some amazing rates a few months ago, but that does seem to have caught on to these great rates,